Okay, let's dive right into this explainer. Today, we're taking a virtual field trip to the lush, absolutely vibrant forests of Peshmari in Madhya Pradesh. We're going to step into the shoes of a nature scientist to explore the beautiful, intricate interdependence of plants and animals found in this chapter. If you've ever wondered how literally every single living thing in a forest relies on the others to survive, well, you are in the exact right place. Let's get going. I mean, think about a bustling water body out in the wild. Nature is totally full of amazing creatures, right? Everything from massive buffaloes down to the most delicate birds and tiny little frogs. In this explainer, we're going to explore the unique features of these living things, figure out how they adapt to their environments, and see exactly how they form a really delicate, interconnected community right around us. So here's our trail map for today. First, we'll talk about exploring the trail itself, followed quickly by some essential forest safety rules. Then we'll look at some amazing animal adaptations, zoom way in on tiny animals and leaves, and finally, we'll bring the whole shebang together by looking at the web of life. All right, part one, exploring the nature trail. Let's set the scene for our big adventure. Our guide on this journey is Abha Didi. She's a nature scientist, which means she literally dedicates her life to studying plants and animals right in their natural habitats. And as she leads us into the Pashmarhi forest, she gives us our very first lesson. Our main goal is to observe. Whether we're looking at tigers, monkeys, snakes, or eagles, our job is just to watch and learn, without ever harming them or disrupting their home. Moving on to part two, forest safety rules. Before we head deep into the trees, we gotta lay some ground rules. The absolutely crucial lesson here is that experiencing nature means leaving zero trace. Remember, when you visit a forest, you're a guest in someone else's home. That means absolutely no teasing or feeding the wildlife, because feeding them actually messes up their natural foraging habits. And we definitely do not bring in polythene bags or leave any garbage behind. A true nature scientist respects the environment entirely. Okay, part three, amazing animal adaptations. Let's see how these creatures actually survive out there. So, as we approach a nearby pond, we get to play detective. Looking at footprints in the mud is a fantastic way to guess who's been visiting the water hole. Is it the heavy, distinct pad of a tiger? Maybe the delicate little hooves of a deer? Or the small hopping prints of a rabbit? Just being observant of the ground tells us a whole story about the animals we might not even see face to face. And when we look up, comparing different birds reveals some incredible secrets about their survival. Just think about the eagle versus the sunbird. An eagle has this sharp, heavily curved beak and razor-sharp claws, which are perfectly adapted to catch and tear its prey. But a sunbird? It's rocking a very long, slender beak designed to reach deep into flowers just to drink nectar. You can literally guess a bird's exact diet just by checking out the shape of its beak. You know, you can actually test this whole concept yourself at home. Try picking up different foods with random household tools. Imagine grabbing a slippery piece of fruit with a spoon versus, say, stabbing it with a toothpick. Or try picking up tiny grains of rice with chopsticks. It quickly shows you just how specialized a bird's beak really is. Their beaks are literal tools that evolved over thousands of years for their specific diet. If you really want to be a nature scientist on the trail, you should start recording these details in a bird diary. By quietly focusing on one bird at a time, you can track its head and wing colors, the exact shape of that specialized beak, and its unique behaviors. Jotting down where it sits and how it moves helps you identify the unique features of literally every species you spot. It's super fun. Oh, and as we look back at the water, we might spot something that looks totally prehistoric. A gharial. This is a very special type of crocodile. Notice its defining feature? It's got this incredibly long, narrow, pointed snout. Just like the bird beaks we talked about, its snout is a perfect physical adaptation. That super narrow shape allows it to whip its head through the water with almost no resistance, so it can quickly snap up slippery fish. We also see how other water animals move and protect themselves. Fish use their fins to glide effortlessly. Turtles have developed webbed feet for swimming, plus those strong, heavy shells to keep them safe from predators. And frogs? They're the ultimate adapters, evolved to live perfectly both on land and in the water. Every single feature has a very distinct purpose. Right, moving to part four, tiny animals and leaves. Let's zoom in even closer. If you're walking through the grass, a grasshopper might suddenly jump right out in front of you. But how do we know for sure it's an insect? Well, it perfectly matches some very specific characteristics. To officially be an insect, an animal must have exactly 3 pairs of legs, so 6 legs total, and 1 pair of antennae to sense the world around it. Plus, a lot of them, like our grasshopper friend, have wings.
But hey, it's not just the animals that have unique adapted features. Plants are incredibly diverse too. Closely inspecting a simple lemon leaf reveals so much. It's green and oval, sure, but if you touch it, it's remarkably smooth. And if you smell it, you get this distinct, strong citrus scent. These textures and smells aren't just for show. They're often adaptations to deter bugs from eating them, or sometimes to attract the right kind of pollinators. This kind of close observation leads to a really fun hands-on activity you can try yourself called leaf rubbing. You just place the rough, veiny side of a leaf under a piece of paper and gently rub a crayon over it. It physically captures the leaf's exact shape and its intricate vein network right on the page. It's honestly like fingerprinting nature. Every single plant species will give you a totally unique pattern. Finally, we arrive at part 5, the web of life. This is where it all comes together. To really understand this, the chapter introduces a brilliant exercise called the Web of Life game. Imagine a group of students sitting in a big circle. Everyone holds a card. Maybe you're a tree, a bird, a fish, or even the sun. The tree holds a ball of yarn and tosses it to the bird because trees give birds a home. Then the yarn goes to the river, which supports the fish. You keep tossing the yarn around, holding onto your piece of the thread, until a giant, beautifully tangled web is formed right in the middle of the circle. And if you picture a vibrant pond ecosystem in the real world, it's basically a live-action version of that game. Every single living element you can think of, the water, the ducks, the plants, the little rabbit on the shore, the bird up in the tree, they're all essentially holding a piece of that yarn we just talked about. They all physically and biologically connected to one another. But here is where the narrative takes a really dramatic turn. Imagine looking at that tightly woven yarn web from our game, and suddenly one person lets go. What if we remove just one player? What if the plants disappear, so the rabbit has literally nothing to eat? Or what if the deer goes missing from the tiger's environment? As the chapter so brilliantly puts it, watch how the web weakens or collapses. The absolute core takeaway from this explainer is that losing even one tiny insect, one specific plant, or polluting one small pond doesn't just affect that single species. Because of that invisible yarn, that intricate interdependence, it weakens the entire ecosystem. Everything in nature is fundamentally connected. So I'll leave you with this final thought to ponder. If we are also players in this web of life, if we hold a piece of that yarn too, what happens if we don't follow those forest safety rules? What is your personal role in protecting the harmony of this incredible interconnected world? Think about that the next time you step out of your door and into nature. Thanks so much for joining me on this explainer, and keep exploring.